Welcome to the digital learning platform of Center for NEMS and Nanophotonics, Department of Electrical Engineering, IIT Madras.
Formation of silicon oxide layers in low-pressure CVD system. In semiconductor technology, silicon oxide layers are mainly used as dielectrics in microelectronics and MEMS applications. The simplest way to produce silicon oxide layers on silicon substrates is the oxidation of silicon by oxygen. This process is performed in tube furnaces, in our case horizontal tube furnace. The deposition of thermal oxide is carried out at low pressure. There are several established methods. Here we will show the low temperature oxide process, where depleted silane reacts with oxygen at approximately 450 degrees Celsius, that is pyrolysis of silane. Here is our custom-built LPCVD system. This is a multi-stack furnace system for growing polysilicon, silicon nitride, silicon oxide and nanowire. Process start. Before starting the deposition, we need to check the gas lines, chillers, pumps, etc. For this oxidation, several gases will be used, such as nitrogen for purging, silane and oxygen for oxide growth. Once we make sure that the gases and the pumps are all operational, we switch on the LPCVD system, that is, controller and power supply. Next, we switch on the interfacing computer and start the machine. Now we will go to the master CVD window to load the recipe. In the master controlled page, there are two windows, Alarm and EGC. EGC unit is there for reducing the effects of the toxic gases and their byproducts after use. We set the temperature of EGC unit at 770 degrees Celsius. It takes around 1 hour to reach the temperature. Once the EGC unit is ready, we load our LTO recipe, followed by purging the chamber using nitrogen. Purging will be continued for 30 minutes. Loading. After purging, all the valves and pump lines are kept closed and the pressure of the chamber reaches to the atmospheric pressure. Next, we will start the loading. Note that we should load our sample silicon wafer for oxidation immediately after the RCA cleaning. RCA cleaning video will be available in our website. The cleaned silicon wafer, 4-inch, is placed in between the dummy silicon wafers to maintain uniform flow of gases, resulting uniform growth. Actual process. After loading the wafers, we close the chamber and start the reset program. Now the process will be continued automatically according to the recipe loaded. Temperature 450 degrees Celsius. Gas flow rates: silane 17 SCCM and oxygen 70 SCCM. Pressure 300 millitorr. Time approximately 2 hours for 800 nanometer oxide layer. Unload the sample and shut down. After the recipe runs successfully, ready to unload signal will come. Once the temperature of the chamber reaches 400 degrees Celsius, we can unload our sample. The nice oxide color is visible. After unloading and closing the chamber, remaining toxic gases should be evacuated from the chamber and the gas lines. Next, switch off the EGC unit once the heater temperature is lower than 100 degrees Celsius. During the cooling, nitrogen flow needs to be continued. Exit all the windows. Shut down the PC. Switch off the power supply. Close all the gas valves. Switch off the chiller and water pump.